Hi everyone, so my name is Clara Bove and I have been working for almost 3 years as a design plus machine learning researcher at AXA, and I am also a PhD candidate at the Laboratoire Informatique de Paris at Sorbonne University. And my research emphasizes on explainability in machine learning in the context of interaction between a human and a smart system. And today I will be presenting you my latest research on how to explain the machine learning prediction to non-expert users. Before presenting it, let me talk about the challenges of applied machine learning and give you a little overview of what are the current hot topics that animates the research communities. And I am going to illustrate these challenges with real-life examples. Back in 2017, Facebook was training 2 conversational robots, Bob and Alice, to communicate between each other to complete some task. And this is actually a screen of one very odd conversation that they had that makes absolutely no sense in the eye of a human. It took quite some time for scientists to realize that it was not a bug, but a new language that the 2 robots developed on their own to actually complete the task faster. And the model behind was so complex that none of the scientists was able to understand at first that it was indeed a new language. And it raises the challenge of transparency of black box models. Models are trained to be more and more accurate, but as they are getting more complex to achieve that goal, they are also becoming more, less transparent. So how do we make sure that we can keep an eye on the prediction process? Because it can raise some other problems. What if the model gives biased predictions that we cannot detect? In this example, so COMPASS is an algorithm for predicting recidivism risks for prisoners in the US. And in 2018, we realized that this algorithm might actually appear biased for Black people, as they were more often predicted as high risk of recidivism than for white people without justifying why. And maybe it is because the dataset that is used to train the model is representing first a biased society where Black people get more arrested than white people. So we might risk taking biased decision with artificial intelligence and put someone's life at jeopardy. And the last example I want to share is this event that happened in Arizona in 2018 during a self-driving car test. So it's a Uber self-driving car prototype that was involved in a crash accident that killed a 49 years old pedestrian. And the car was not trained to actually detect the pedestrian here. It didn't recognize the pedestrian from the back, and it didn't recognize neither that he was crossing the street outside the pedestrian crossing area. A human would have identified the situation naturally, but the system, it's too complex, so it's not able to do it. So for safety and robustness reason, it is important to take the time to teach a machine the complexity of society. So main challenges in applied AI are towards first the transparency with the questions of interpretability and explainability. Second, responsibility with the questions of bias and fairness. And finally, accountability with the questions of safety and robustness. And in regards to transparency, my research focuses on explainable AI, and I am going to present you what it is, the main challenges, and my latest work. So, as previously said, on one hand, we have some machine learning algorithms that tend to be more and more accurate at the expense of explainability. And on the other hand, we receive more pressure from regulators and government to make sure that we use AI in a responsible way. On the GDPR regulation, one article specifies the right to explanation for any automated decision. And even if we don't have yet an explicit definition of what an explanation is and what type of explanation we should provide, it is clear that transparency will be more and more required. So all of this encourages a search for interpretability in research communities. And there is many definitions for interpretability, and here are 2 definitions that are commonly accepted in the literature. The first ones identify it as the degree to which a human can consistently predict the model's result, and it is more related to the work that is conducted in the computer science research community. The other one defines it as the degree to which a human can understand the cause of a decision and is more related than to the work that we conduct in the cognitive science and human-computer interaction research fields. There is different methods that we can use to extract explanation today, considering if the model is simple, so we call them the white box models, because they are simple enough. We don't need any methods to interpret them. We can read the algorithm and interpret and extract some explanation ourselves. And for some other model that I consider too complex and opaque, that we call the black box model, we applied interpretability method that analyzed the model after the training. And for those models, so the black box models, here are the main type of explanation that we can extract. So first, feature importance explanation as weight of the feature or attributes on the prediction. We have also rules explanations as global overview of the model behavior that applies to all prediction. We have neighbor instances explanation as nearest use case in the dataset to your instance. And finally, counterfactual explanations as an example of the minimum changes to make in your feature values to get a different prediction. And here is what it looks like. And as you can see, we are still quite far from what we can give to customers so they understand them. So here, so that's where the Explainable AI community comes into play. Within this research community, we aim at making AI system more transparent so people can make informed decisions. Providing interfaces which help explain why did you get this prediction and how the system predicted it, and analyzing people's perception of explanation in machine learning. I am going to briefly share with you my latest work that has been published at the International User Interface Conference this year at the workshop called Transparent and Explainable Smart System. And this work is on the contextualization of one type of explanation that I described, that is feature importance for non-expert user. As our aim is to present explanation to a user about why he or she gets a specific prediction, we are going to talk about local explanation. So in the state of the art, we started to investigate what is an explanation from a social science perspective, and we found that around the explanation itself, there is numerous additional information that is required by the person who received the explanation to be able to understand it correctly, like contextual information, intention of the explainer, etc. We also investigated what local explanations can be extracted from various interpretability methods, and we selected the feature importance explanation type as extracted from SHAP method as the one that could actually best explain why a user gets the prediction in a regression scenarios, because we will see afterwards we applied what we proposed in a machine learning pricing scenario. And finally, we investigated which explanations are actually presented to which kind of users. And for non-expert users like clients and prospects, we can see new ways of presenting explanation through interactive interfaces. But yet, so that's what you can see on the illustration. We believe that there is more work that needs to be done in order to make this explanation more accessible, comprehensible, and useful for end users. So in our proposition, we proposed XAI principle for designing and presenting local feature importance explanation by contextualizing them. We contextualized explanation at 4 levels, responding to non-expert user pain point that we identified while they were interacting with machine learning prediction and explanation. The first is machine learning transparency that aim at providing guidance regarding how to interpret the explanation. Then domain transparency to compensate the lack of causality in explanations and provide a brief justification about how this feature might impact the outcome. Also external transparency to mitigate biased interpretations of the explanation and provide additional external information that may have an indirect influence on the outcome or the algorithmic process. And finally, contextual display to help the user find a logical path in the data and build better mental model of the explanations. We applied these principles in a car insurance machine learning pricing scenario. Here, a prospect wants to subscribe to a new car insurance plan, and the price is calculated based on the shared personal information. And together with the price prediction, we provide contextualized local feature importance explanation about the price calculation. We started also a pilot study to evaluate the efficiency of our proposed principle to improve understanding and usefulness of explanation. And to do so, we conducted an online A/B test with one version of the interface that didn't apply without our principle, so that you can see on the left, it's prototype A. And then one version of the interface where we did apply our principle on the right. We measured objective understanding with a series of questions, and we also measured subjective understanding and usefulness with the 6 Likert scale. And the very preliminary results indicate that there is an improvement of objective understanding with our principle. There is also an improvement of subjective understanding and usefulness. And without our principle, what we collected is that explanation can appear more confusing. And with our principle, explanation helps to actually make an informed decision. So therefore, it encourages us to continue to explore contextualization as a means to enhance the understanding and usefulness of local explanation. We are currently defining more principles on the contextualization and interaction of this type of explanation, and we will conduct a larger study this summer. So that's some of my latest work, and I am quickly going to introduce also my team's work and what is our vision on the current AI landscape for insurance. Our team at AXA is dedicated to work on how we can have a responsible use of AI in our project, and we work first on governance to assess the question of who is accountable for this. We also work on the main challenges that I mentioned earlier on fairness, interpretability, and safety. And we also proactively work with regulators and ethics on ethics and regulations of AI. You can find some of our papers on the GitHub links that it's at the bottom of the slide. And concerning the landscape of application of AI in the insurance industry, here are some domains that we are currently working on. So first, everything around digital assistants that we can use for internal services like finance to manage better the purchase orders, IT services or HR request management, etc. And we can also use it for external services like in call centers, for dedicated services for our customers, or in FAQs that we have on our websites, etc. There is computer vision that we can use for detecting potential fraud on claim submission by analyzing the PDFs that we receive, or we can be using it for satellite images to assess real-time risks. Also for machine learning and deep learning, we can be using it for risk management and pricing model. And finally, knowledge management and rule-based system can be used for automatization of our contract and claim management. Thank you very much for your attention, and you can get all my contact information here. And if you have any questions, do not hesitate to raise them.